solving systems of equations. Using substitution. Now we've done this before, so this should be reviewed, but I'm going to make sure that I teach it, okay? So we'll start by, let's solve example 1. If I had y is equal to 4x minus 6 and y is equal to x plus 3. Now with the system of equations, you will have 2 or more equations that are written with 2 different variables, okay? So what I'd like to do is I need to find out what the value of x is, what the value of y is. Now if you notice, both of these equations say that y equals. So the first thing I'm going to do is take these 2 and set them up to be equal to each other. So I'm going to take 4x minus 6 and set it up to be equal to x minus 3. If you notice, there's only one variable in this particular equation now, is the variable x. So when I solve this, I'll know what x is equal to. So I'm going to transform this x by subtracting x from both sides. I'm not going to leave out any steps for you. I'm going to make sure I write down everything. X minus x gives me 0, so I'm left with a 3. 4x minus 1x gives me 3x, so I get 3x minus 6. Now I have a 2-step equation. I need to transform my 6, and I'll transform it by adding 6. Now I have 3x is equal to 9. Divide both sides by 3. So x is equal to 3. So I know my value for x. So for my second part, I'll take one of these equations. It doesn't matter which one I use. I'll take the second one, and I'll say y equals x plus 3. I'm going to substitute this 3 for x. So I'll get a 3 plus 3. So my y is equal to 6. So the solution for this problem will be an ordered pair. Remember, an order. Order means something. So in the ordered pair, the first number is going to be my x. The second number will be my y. So the solution for this problem is the ordered pair 3, 6. That means that if I substitute the 3 and the 6 in their proper place up here, that it would satisfy both of these equations. So let's just check it right quick. All right, my y is 6, so if I put a 6 here, I'll have 6 equals, my x is 3, so 4 times 3 is 12. I have 12 minus 6, so I get 6 equals 6, so that checks. Using the second one, put that 6 in the place of my y, substitute the 3 for my x, so I get 6 is equal to 6, it checks. So you can always go back and check your solution. So sometimes it will be written where both a variable has been isolated for the same variable in each equation. So let's look at example number 2. For example 2, if I had y is equal to 2x plus 1 and 3x plus y is equal to a negative 9. Well, if you notice, on one of the equations, a variable has been isolated, y. So I'm going to take the second equation, and I'm going to substitute 2x plus 1 for y in this equation. Be very careful when you're doing your substitution. Once you've done your substitution, look at your equation to make sure that you have the same variable. You can't have 2 different variables. I only see the variable x. So now I'll solve this equation. 3x plus 2x gives me 5x. Now I have a 2-step equation. Transform the 1 by subtracting 1. As I simplify, I get 5x is a negative 10. Divide both sides by 5 because 5x indicates multiplication, inverse is division. So x is equal to a negative 2. So I know what x is. Now go back to the equation that reads y equals. And I'm going to substitute that negative 2 for my x. 2 times a negative 2 is a negative 4. And a negative 4 plus 1 is a negative 3. The solution for this problem is the ordered pair. X is a negative 2, y is a negative 3. So the solution is an ordered pair, negative 2, negative 3. Example 3. If I had x plus 2y is equal to 6, and 3x minus 4y is equal to 28. Now, if a variable has not been isolated for you in either equation, what you do is look at your two equations, see if there's an equation where the numerical coefficient for one of the variables is a 1 or a negative 1. Well, if you notice in this first equation, the numerical coefficient for x is a 1. So I'm going to take that first equation and I'm going to isolate the x. So I want x to stand alone, so the 2y needs to be transformed to the other side. I see addition, the inverse is subtraction, so I'll subtract that 2y from both sides. So now I've got x is equal to 6 minus 2y. For my second step, I'll take the second equation that I have not used. I highly suggest that you write down the equation that you're using. Now I'll substitute in the place of x, I'm going to put 6 minus 2y. So this reads 3 times x right here. So I'll be 3 times, put this in the place of x, 6 minus 2y. Again, always check to make sure that you have the same variable on that line. I only have the variable y. Use your distributive property and clear the parentheses. 3 times 6 is 18. 3 times a negative 2y is a negative 6y. If you notice, you have some like terms. So combine those like terms. That dash makes the 6y negative, dash makes the 4y negative. So I'll end up with 18 minus 10y. This 18 is positive. I need to transform it to the other side. So I'm going to subtract 18 from both sides. I have a negative 10y is equal to 10. Divide both sides by a negative 10. So my y is equal to a negative 1. So on this, I'm going to have a part C. For part C, I'm going to go back here where I have isolated the x and write down x is equal to 6 minus 2y. I'm going to substitute that negative 1 for y. As I simplify, I get 6 plus 2, which gives me 8. So the solution for this particular problem, x is 8, so that's the first number in my ordered pair. Y is a negative 1, so I get the ordered pair 8, negative 1 as an answer. Example 4. Y equals negative 4x plus 12 and 2x plus y is equal to 2. Again, looking at the two equations, a variable has been isolated in one of them in that first equation. So for my first part, I'll take the second equation and I'm going to substitute a negative 4x plus 12 for my y. As I simplify, 2x minus 4x is a negative 2x. Transform the 12 by subtracting 12. I get a negative 2x is equal to 2 minus 12 gives me a negative 10. And this should be a negative 2x, I apologize. Divide both sides by a negative 2. So I get x is equal to 5 for my part B. Go back and pick up the equation that reads y equals. Substitute that 5. So I get a negative 20 plus 12, which gives me a negative 8. So my solution for this problem is the ordered pair 5, negative 8. I want to make sure that you've got this. So let's do just a couple more, 1 or 2 more examples, so that'll be it.